Let's take a look at an SCR Thyristor, okay? Now, this is how they're made up. They're a PN unit, okay? Now, the center here is it's reverse biased, so there's no free holes or electrons. So in this state, nothing's going to pass through there, okay? That's a depletion region in the center there. So now, if we add electrons to the gate by putting a positive charge on there, we can turn the P region into an N region, and that makes it into just a PN junction here, and it just makes it into a diode, okay? So once the power, current's running through there, that stays an N junction there, an N material, and it just turns into a diode. So that's how the unit's going to work, and the only way to turn it off is by reducing the anode current, okay? Now, we want to find R1 here, okay? So here's the formula for R1. R1 is going to be equal to your source voltage minus your VGT, which is the gate trigger voltage. And in the data sheet on this one happens to be a BT151. That's 0.7 volts, okay? And then we divide that by IGT, right, which is our gate trigger current. And in the data sheet, it's 4 milliamps, okay? So we take our 12 volts minus our 0.7 divided by our 4 milliamps. So that comes out to 2,825 ohms for this resistor. I didn't have that. I had a 2K7 there, so that's what we put in there. Now, if I take the 4 milliamps and divide that into the 0.7 volts, that comes up to 175 ohms. So this junction here is about 175 ohms. And if I put an ohm meter across there, it reads about 200 ohms on there. Now, basically we have two resistors. We have a voltage divider here. So we'll use this voltage divider formula and see if that comes out right. So we have the resistance between the gate and the cathode. We use K for cathode because we used C for collector, so we use K for cathode, okay? And so we take our R1 plus the RGK resistance and divide that into RGK, so it's 175 ohms. We divide that thing out and times it by 12, we get our 0.7 volts. So that all works out fine, okay? So we're going to try it. There we go. Let's see what we got there. I'll turn that on and turn that on. Can we see that? So let me turn this on here. Now, if I turn the unit on, I have 3.9 4 milliamps there. That's good. And over here I have 0.765 volts. If you can see the 4, yeah, you can see the 4 milliamps there. Okay. So, of course, if I take the gate current off, I'll have zero current, but I'm still having my voltage drop across there, my 0.7 volts across there. So that works out fine. Okay. Now, in order to turn that off, we need to either turn the power off, okay, like that. So that comes off, and we can turn that back on. Now, this one over here, I have it set up. There's 3 different ways to turn the unit off, okay? And if I turn that off, we got to put the power in there, and I turn that on, okay? That one's on, and now I can turn that off by just turning off the load there, right? Okay, turn that back on, and then we can just short it out like this. We can just short out the from anode to cathode, and that's what that does. That just shorts it out. If you keep that on, of course, the load's going to come on. And then the other way to do it is to have a capacitor across here with this 4.7 k ohm resistor there, and we turn that back on, and then I can push this button here and take that resistor to ground and turn the unit off. Okay, I like that method the best. It goes off immediately, and this one here, of course, as long as you hold it in, it's on. But this way, it turns off immediately. And so that works out good. So that's the 3 ways to turn it off. Now we'll take a look at this one here. Okay, this one's going to be easier to look at here. And this is that happens to be the cathode there. Okay, and here's the anode over here. Okay, can we see that? Now, if I take this resistor from the, we'll turn that on. This is our gate here. The white one's the gate, and I'm just taking the resistor from the power here and turning that on. Okay, and then to turn it off, we can do several. This is the cathode here. I can take the cathode to the anode. This base is the anode here. So I take that to there, and that just turns it off. Okay, and let's turn it back on. And then, of course, I've got a capacitor and a resistor down here, and I can take that to the cathode here and turn it off that way. There we go. So that works the same way as these little ones here. This one is only about 20 ohms across between the gate and the cathode, and this one's about 180 ohms there, 175 ohms. But that's an SCR, and this one's good for about 300 amps. But that's the way you control them. And hopefully in the next video I ordered some GTOs, a gate turn-off SCR, where you can just use the gate to turn it on and off. So we'll give those a try later. But that's it for now. Thank you.